These are the notes for section 3.2, angles and parallel lines. Our objectives are I will be able to use properties of parallel lines to prove angles congruent and supplementary, and I will be able to use algebra to find angle measures. So we talked about corresponding alternate interior, consecutive interior, alternate interior, and same side exterior angles last time. So why they're important is they have special properties whenever the lines are parallel. So the corresponding angles postulate says if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So remember the symbol for congruent was the equal sign with the tilde on top. So it said corresponding angles are in the same position. So if I take a look at these two that I circled in black, these two circles, basically the one on the left is angle 1 is congruent to angle 3. And I have the one down below, that's angle 8 and angle 6. So angle 8 is congruent to angle 6. I have 7 and 5 all in the same position. Angle 7 is congruent to angle 5. And lastly, I have 2 and 4. So angle 2 is congruent to angle 4. This only works if the lines are parallel. Similarly, we have alternate interior angle theorem. This says if two parallel lines are cut by a transversal, then each pair of alternate interior angles is, congruent. Again, this is the congruent symbol, the equal with the tilde. So remember, we have the interior between the lines and alternate interior on opposite sides of the transversal, not adjacent. So that's angle 4 and angle 5. And my other example is angle 3 and angle 6. So if you had a good grasp on what these angles were in the last section, it should be a very easy section for you. The consecutive interior angles theorem. Again, I have my interior right here. This says if two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. Remember, supplementary meant they add up to 180. So I have angle 2, and on the same side, remember this is my transversal, the one that cuts through the two lines. So angle 2 plus angle 3 equals 180 degrees. I guess I should be using this M for the measure of angle 2 and the measure of angle 3. Just the same way, the measure of angle 7 plus the measure of angle 6 equals 180. So now we have the two exterior angle theorems, the alternate exterior and the same side exterior. So for the alternate exterior angle theorem, if two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. And just to reiterate, all of these are whenever we have parallel lines. I know I circled it up in the first one, but I have not done it throughout. So they always have to be parallel lines. So we have our exterior above and below. So we have angle 2. Remember, on the outside, not consecutive, different sides. These are alternate. So angle 2 is congruent to angle 7. We also have angles 1 and 8. So angle 1 is congruent to angle 8. The The last one is same side exterior angle theorem. If two parallel lines are cut by a transversal, then each pair of same side exterior angles is supplementary. Again, supplementary means they add up to 180. So we have the exterior, interior, exterior. So this is the same side, so there's angle 1 and angle 4. So the measure of angle 1 plus the measure of angle 4 equals 180. And we also have the measure of angle 8 plus the measure of angle 5 is equal to 180. Now that we have this, we can do some problems. So we're told L is parallel to M. If we wouldn't have that, we couldn't do any of these problems. It says state the type of angles given. So remember, state the type of angles given and find the measure of the missing angle. So I'm going to be doing a lot of erasing here. But for number 1, I'm told angle 7 is 100. And angle 3, well, that has to be 100. Because these are alternate interior angles. I'm going to be using abbreviations. So that means it has to be 100 degrees. For number 2, we're told the measure of angle 7 is 95 and to find the measure of angle 6. These are consecutive interior angles, CIA. So that means 95 plus x equals 180. So that has to be 85 degrees. If I'm going too fast for you, make sure to pause the video. Measure of angle 1 is 120 degrees. What's the measure of angle x? Those are alternate exterior angles. So that means they're congruent. They have to be the same. So our next example says the measure of angle 4 is 20. What's the measure of angle 5? You have to think all the way back to Unit 1. This is a linear pair. We haven't talked about in a while. They're supplementary. So 20 plus x equals 180. That means it has to be 160. So try 5 and 6 on your own. So for this one, I want you to try 7 and 8 on your own. We're going to do number 9. Again, let's read the directions. Find the value of the variable if L is parallel to M. So since these are parallel, we have the parallel marks for 9. So there's L and there's M. We have to see what to do with these things where they both have X. Well, these are same side or consecutive they are same side exterior angles. So same side exterior angles. So that means they add up to 180. So we have 6x minus 11 plus 5x minus 7 equals 180. When I combine like terms, I get 11x minus 11 minus 7 minus 18 equals 180. When we add 18, we get 11x equals 198. And then we divide by 11. Hopefully this algebra is all a review for you. So we get x is equal to 18. We need to figure out what this is, so we substitute 18 in. And whenever we do that, we get 97. So that means 6y plus 1 equals 97. These are vertical angles. Vertical angles are congruent. So I have 97 is equal to 6y plus 1. When I subtract 1, 96 is equal to 6y. And lastly, I divide by 6, and we get y is equal to 16. This is the hardest one. 7 and 8 are easier than this. Just remember to use your properties, and hopefully that'll make sense. If you have any questions, make sure to ask me, and I'd be happy to help you.